All right, so we're going to talk about 10.1 here. This is the kind of the intro at the beginning to what's called polar coordinates. And what this section will start to talk about is it's going to be another way to represent graphing a particular point. So we're used to what's called rectangular or Cartesian coordinates when we plot a point with coordinates x and y. So I just put a random point here. All right. Now, how we get to that point, of course, would be we go horizontally x units, and then we go vertically y units. Okay, so that means, you go x units this way, and of course y units up or down. So that's one way to represent a point, and we do it in rectangular coordinates. To represent a point in what's called polar coordinates, instead of figuring out, okay, is it x and y, what it does is it takes into account, okay, how far from the origin, what's the distance from the origin that a point is. So it takes this line directly to the point, and then it also takes into account the angle it makes with the positive x-axis. So remember, it's an angle in standard position. All right, so I'm going to call this r, which we know if you look at this picture, it looks like the hypotenuse, right? And then it also takes into account theta. So the other way you can represent this point would be in terms of, again, distance from the origin, which they call r, and then theta, which is the angle, okay? And we can do this in any quadrant. We could also hit the poles as well, as we'll see a few examples in upcoming videos, all right? But one of the relationships that we can use here, okay, is if we recognize that, if I ask you what's the cosine of the angle here, well, we've seen this plenty, all right? Cosine of theta is going to be your adjacent over hypotenuse, okay? Which means if I rearrange this, the x-coordinate is going to be r times the cosine of theta. So that's one relationship we can use, and again, we'll see this throughout the section. Now, of course, if we're using cosine that relates to the x-coordinate, that means sine of theta will deal with the y-coordinates. Remember, sine, all right, so sine is going to be opposite over hypotenuse, okay? So opposite over hypotenuse. So therefore, the y-coordinate is going to be given by r sine of theta, okay? And then some other relationships that we can use. Of course, we said r looks like the hypotenuse of this triangle, okay? Which it is. So of course, good old Pythagorean theorem will come into play. All right, if x squared plus y squared equals r squared, all right? And then another one that might come in handy as well is if you do, I'm going to put a trig function in front of theta here. So it's some function of theta. So I'm going to put something here in a second, right in front, okay, is going to equal opposite over adjacent. Now, what is opposite over adjacent? We know that as tangent, okay? So we got this, we got this, we got this, and we got this, okay? So put these kind of into your toolbox as we go through this section, okay?